Okay, guys, greetings once again, and welcome to another edition by iCampSA. In this edition, we're looking at the 2025 pre-June exam, and our focus is on statistics, specifically question 1. So this will be the paper that was written by the grade 12s that are based in Limpopo. So let's have a look at the question. So for question 1, we are given the statement that the data below shows the number of people visiting a local clinic per day to be vaccinated against measles. Okay. So we're given the number of people, and this is made random. And then the first thing, we are required to determine the mean of the data. Okay. So let's go ahead and have a look at the question. But what I want us to do first is to quickly do what is very important, which is to arrange the data in ascending order. So what that means is we should arrange the data from smallest to the biggest. So if you observe carefully, what we are going to have is a 5, a 12, a 13, and then 15, 18, 18, then 19, 20. If you observe carefully, you'll have 21, 21, and then you'll have 22, and then 23. We have more. If you observe carefully, you have another 23, so we'll have another 23, and then 26, 29, 33, 35, and the last one, which is 37. Okay. So with this in mind, we can go now and have a look at the first question. So 1.1. We are required to find the mean. Okay. And remember that for our statistics at this point, our mean is going to be denoted by x dash, and it will always be the sum of x, which is whatever data we have, divided by n, which is the number of data points. So if you observe carefully and you quickly do a count, you'll see that you have 1, 2, 3, 4, and then you have 1, 2, 3. So that's 4 by 3, that is going to be 12. Okay. And then 13, 14, 15. My apologies. If you look carefully, this is going to be 4 by 1, 2, 3. And then if you look carefully, 4. So it's 4 by 4, that is 16, and 17, 18, 19. So it's 19. So our n becomes 19. Okay. So we can go now and find the sum of these terms. So if we go ahead and work out the sum of x, which is just that sum there, you'll have 15 plus 12 plus 13 plus 18. Sorry, plus 15. And then plus the rest, which is 18 plus 18. Let me populate the others. Then let's put in the last three numbers. That is plus 33, then plus 35, and then plus 37. So if you go to your calculator and find the sum of these numbers, you will see that you end up finding 410. Okay. And we know the formula for the mean, so we can go ahead and calculate our mean. So therefore, our mean will simply be 410 divided by 19. Okay. And if you go ahead to your calculator, 410 divided by 19, you should be able to see that you get 21.58. Okay. That is what we end up getting. So this means we're done with question 1.1. Okay. Now let's go to 1.2. Okay. So for 1.2, what you need to remember is we're looking for our standard deviation. And our standard deviation is denoted by the sign that wants to look like a 6. And it is given by the square root of the summation of the difference between x and x. Sorry, of x and the mean. And all of that should be squared and we'll divide by n. Okay. So what I suggest that you do whenever you're looking for your standard deviation, what you should do is use your calculator. Okay. So there's a way which when you go to your calculator, you put in all these numbers. You put in a table, you put in your 5 until, then you can do shift and then find your standard deviation. Okay. And what you will do if you use your calculator, because look at the marks allocation, they're not expecting you to go the long way. Okay. So you will see that the marks or your standard deviation, when you go to your calculator, you will end up finding that your standard deviation is simply 7.94. Okay. So that is what we have as our standard deviation. Then let's look at the next question, 1.3. Determine the number of people vaccinated against measles that lie within one standard deviation of the mean. Okay. So let's go ahead and have a look at what this means. So we're looking at 1.3. And this will generally be how they ask these questions. So what we are trying to understand is standard deviation from the mean. Okay. So you'll see sometimes they will say one standard deviation or two standard deviations. Okay. So what does this mean? Well, what this means is we will need two boundaries. Okay. So you will need the upper boundary and you will also need the lower boundary. Okay. So let's go ahead and figure out how do we find this upper boundary of ours, which we apparently need for this problem. So let's have a look at our upper boundary. So how you find your upper boundary is always by saying the mean plus. So since they're saying the one standard deviation, I'm going to have a 1, and then that 1 will multiply our standard deviation. Okay, then let's have a look at our lower bound. Okay, so for our lower boundary, we are going to deviate from the mean. So here's our mean, but we are going to have minus 1 standard deviation. So I'm going to have 1 times our standard deviation. So if they were saying 2, it would be 2 times the standard deviation. Okay. Now, if we go and solve this, I'll just have upper boundary. This is going to be, our mean is 21.58 and then plus 7.94. Okay. And what you should realize is that we will end up having for our upper boundary, we're going to have 29.52. Then let's have a look at our lower boundary. So we should do 21, which is the mean, 21.58 minus 7.94. Okay. This becomes our lower limit of the boundary, and that becomes 13.64. Okay. So now that we have this, we need to figure out how many clients fall within the, when we look at the days, how many clients do we have which are within this one standard deviation from the mean? Let's have a read again. Determine the number of people vaccinated against measles that lie within this. Okay, so let's go ahead and deal with this question. So I'm going to need this on the next page. Okay, so this means here, if you look carefully, when we look at the number of people who are vaccinated, so if we observe the number of people who have vaxxed, we'll look at this within this boundary here. So we look at an element from 13.64 up until, if you look at the deviation, 29.52. 5, 2. So now what we need to do is let's go and fetch this data here, which speaks to the number of people who visit the clinic to be vaccinated per day. And I'm going to share what I think about this question. So what I think it should have been that how many days do we have people, did we receive a number of people that fall within one standard deviation? That was how I think this question should have been asked. So what I'm going to say here is about this question here is that the question here is not well phrased. Okay, so it is not well phrased. For a simple reason, whenever you're dealing with questions like this, what this here tells us is it tells us about the number of people who came to the clinic per day. Okay? So now, if you think about it carefully, the question then should be looking along the lines of how many days, of the total days where we're measuring the people, have a number of people that fall within one standard deviation. Okay? So it is within. So if you look carefully, we need to look for numbers that are between 13.64 and 29. Okay? So if you observe carefully, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. So if you look carefully, that is 12 numbers, but there's something that I quickly want to correct. And if you observe carefully, let's just look at 18. You'll see that we have an 18, 18, and 18. So there are 3. So I'm missing one of them here. So we have another 18. So if you look carefully, that becomes 13. Okay. So if you look carefully, we have 13 days that have a number of people that fall within one standard deviation. So that there, guys, just becomes our answer. So this is what we have, and that becomes our answer. Okay. So I hope that this does make sense. And with that said, let's go and have a look at the next question. Determine the interquartile range of the data. Okay. So let me quickly fix this data here and we give it a shot. So we have 1.4. Okay. So let's take this data here. So we need to figure out where is Q2 and Q number 3. So let's put in the 18 somewhere there. Okay. Let me just erase all of this. So let's put in another 18. So we're looking for the interquartile range. And we know the interquartile range is given by Q3 minus Q1. Okay. So what I'm going to try and figure out is what is Q1? And for Q1, I'm just going to try and use this formula here, n plus 1. So remember that for n, we have 19. Is that correct? Yeah. So we have 1 over 4 into 19 plus 1, which is going to give you 5. Okay. So remember, where the 5 is at, it is a position. Okay. You shouldn't be confused of this here. So this 5 here, that speaks to position. What does this mean? It means the following. It means I need to go and look for 1, 2, 3, 4, 5. So this here becomes our Q1. Okay. I hope that this does make sense. Let's go and find our Q number 3. So Q3, if you remember, it's 3 over 4 into n plus 1. So this is going to be 3 over 4 into 19 plus 1. So that's 20 over 5 over 4, which is going to be 5. Then times by 3, that's going to be 15. Okay. So what does this mean? It means that we need to go to position number 15. So it means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And what we're getting is 26. Okay. 26 is position number 15. So this means that our Q3, so remember, this here tells us of where the position for our Q is at. So our Q3 is 26, while our Q1 is 18. So our interquartile range is simply going to be 26 minus 18, which happens to be 8. Okay. So our IQR, interquartile range, that becomes 8. Okay. So I hope that this does make sense. So now that we have the interquartile range, we're in a position to go and draw the box and whisker that represents this data. So that is 1.5. So what we want is the box and the whisker. Okay. Something that's very important that we forgot to figure out was Q2. What is Q2? So we can start by going to look for the position for Q2, which is just half of n plus 1. So that's half of 19 plus 1. So our Q2 will be based on position number 10. Okay, let's go and find that. So what we are going to have is 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. Okay, so this is going to be where our Q2 is. So our Q2, remember this here, is for its position. So if we solve, we'll find our Q2 to be equal to 21. Okay. Then for our box and whisker, we can just look at our data here. We obviously always need the max, which is the last number, 37. And we also need the minimum, which is, if you observe carefully, the minimum is 5. Okay. So with this out of the way, we can go ahead and try and draw our box and whisker. So let's go ahead and cook. So I'm going to start off by having a line, straight one. Then I'm going to put in numbers to this line. Okay. So I'm going to put in a 5. Let's try again. So that's going to be a 5. And then a 10. Then 15. 20, 25, and 30, and 35. So we probably might need to move things a bit, okay, so that we can have a 40 at least. So at least you, in your exam, probably will have a graph paper, so it makes life to be a bit convenient, okay. See if we can fix this here. So move the 30 a bit, and then move 35. Now let me move all of you guys like that. Yeah, probably just do that. And then we can now have a 40 somewhere here. Okay. Now with all of this in mind, we can go ahead and draw our box and whisker. So minimum is 5. So we're looking at something that is somewhere there. Okay. And then our Q1, we found previously to be 18. So 18 is just before 20. That's our Q1. And then our Q2, which is found now to be equal to 21. So that is just after 20. Okay. So there we go. And then if we look at our Q3 above there is 26. So that is just after 25. Okay. You can have that there. Then we look at our maximum. Our maximum is at 37. So that's just before 40. So we can have that there. So let's go ahead and have our box. So our box is going to be something like this. Okay. Then we have that is our Q2. We have that is our mean. We have that is our max. Okay. Then we just connect this here. Connect and connect. Right. And if you observe carefully, you'll see that this here is skewed to the left. Okay. But that is what they were expecting you to be able to do. That's our box and whisker. What's always useful is to make labels here because, at times you are not able to draw according to scale. So we have a 5 here. Q1, remember we did find, that was 18. And then the median, which is Q2, we found to be 21. Q3, we found to be 26. Then the maximum is 37. Okay, this will make sure that you do get all the marks that are there to be gotten, guys. So please make sure that you label your diagram, carefully. So this then brings us to the end of this paper here, which was the Limpopo 2025 pre-June exam paper 2, and this was question 1. So please practice, guys, and make sure you understand all these steps that we undertook. Okay, but one thing I need you to realize about how skewed this is, if you observe carefully, your mean we found previously to be 21.58. Okay, and your median Q2 we found to be 21. So if you look carefully, your mean is bigger than your median. And when your mean is bigger than your median, your what you call it, your box and whisker becomes positively skewed. So let's go and make a note of that. And this is very important, guys, that you observe your mean and your median. And if your mean is bigger than your median, then your data will be positively skewed. So let's make this important note. And if you observe carefully, our important note is that our mean is greater than our median. And remember, your median is simply Q2. And whenever this is the case, what we say the graph of the data is positively skewed. So we have positively skewed data set. So that is what happens when you have your mean being bigger than your median. Okay, so it becomes positively skewed. And how you see that is that you will usually have your box like this, and you'll have your median. So if you look carefully, we'll have more space to the right. That is how it becomes positively skewed. Okay, positively skewed. What that means is we have more space to the right of the median. Okay, if you observe carefully, we have more. So we have more space to the right of the median, okay, which is Q2. So remember, the point that is here, that is our Q2, which is also known as the median. This is very important, guys. And if you remember, if ever your mean becomes less than your median, so if your mean becomes less than your median, then what you will realize is that our data is negatively skewed. Okay, what that means is it is skewed to the left. Okay, skewed to the left. What does it mean? It means we have more space to the left. So How is that going to look? It's going to look something like this. So we are going to have our median here, and look at the space that we have to the left of the median. So it's a lot of space, guys. And that is how we have a data set that is skewed to the left. And this is when this condition here is the case, where our mean is less than our median. Okay, very important. So please do make sure that you guys understand this. This would be Q2. Okay, and then you have one where you have your mean and your median being equal. And this one is not skewed to the left or to the right. It is rather symmetrical. Okay, what does that mean? What it means is if you draw your box and you calculate your mean and your median to be equal, we will be split exactly in the middle. So to the left, what we will have is the distance to the left will be the same as the distance to the right. So remember here, you have Q2 and you have Q3 and you have Q1. So if you think carefully, when it is skewed, when it's like this, if you do Q2 minus Q1, you should get the same answer as Q3 minus Q2. This is another check that you can do. But if you observe carefully this side, we have our Q3 and our Q1. For a data set that is negatively skewed, if you do your Q3 minus your Q2, and you find out it is less than your Q2 minus Q1, then this will be negatively skewed. While on this one, if you look carefully, you have Q3 and Q1. So it means another way you can check this is if you do Q3 minus Q2 and you find out it's bigger than Q2 minus Q1, then this here is positively skewed, which is skewed to the right. Okay, so that is what is happening, guys. So I hope that you are able to make sense of all of what we did here. These are very important fundamentals for you to understand as part of your knowledge of statistics. Okay, so let's pause for here, or let's pause here for today or for this lesson. Cheers, guys. Please don't forget to share and share these with your friends which you also want to pass. And this once again is brought to you by iCampSA. Cheers, guys. Hope you enjoyed. Bye.